All right, so today's lesson is 3.2. Here is your warm-up. Go ahead and pause the video, write the problems down and work them through, and then when you're done, come on back and we'll go over it. But make sure you're getting this down on your bell work paper because it does count for points. All right, first problem. I'm looking at my drawing without even looking at anything else. I already noticed something. I noticed that I have a perpendicular sign right there. All right, which to me means since these two angles are, the angle to the left of it is next to it, that means that is also 90 degrees because they have to be supplementary. Okay, so let's see what it says here. The measure of angle TPQ. So TPQ is 90. I already figured that out. All right, the measure of QPS. So the measure of QPS is 7x plus 2, or minus 12, I'm sorry. And the measure of SPR is 5x plus 6, so 5x plus 6. All right, so it looks like if I add 7x minus 12 plus 5x plus 6, I should get 90 degrees. So let's see what I get here. 7x minus 12 plus 5x plus 6 has to equal 90. That is your equation, so go ahead and set it up, solve for x, and find the measure of the missing angles. Problem on the right, given AB is congruent to BC. So right away I'm going to go ahead and mark my drawing. And that means that 2x minus 8 has to equal x plus 17. And then you can go ahead and solve for x and fill in the blanks for the line length segments, or segment line lengths. All right, this is 3.2 for your notebook and your objective. Go ahead and take a minute, pause the video, and write it down. All right, so today we're going to start talking about geometric proofs. Geometric proof is an argument that begins with a known fact. So it's kind of like you're playing police detective. So you're going to have a fact, or you can pretend you're a lawyer, and then you're going to make some brilliant deductions from the facts that you're given, and then you're going to try to prove something in the end. So they're going to give you, at the beginning, they're going to give you some information. They're going to ask you to prove something in the end, and what happens in the middle right here are the deductions and the conclusions. This is where you have to do the work to figure out how to prove something is true or not true. All right, if you are at home, don't bother writing this down. If you want to, you can, but I have a paper slip that's going to be taped into your notebook. So leave about 4 inches of blank space there. All right, so here's the first property that's on your list. This is common sense, and you've probably seen it before. This is called the addition property of equality. If I have two numbers that are equal to each other, for example, if A is equal to B, then if I add the same number C to both sides, the equation is still equal. That's just common sense. For example, if A is 3 and B is 3, if I add C, I'm going to say C is 2, equations are still equal. And the same thing would be true with subtraction. If I start with two equal numbers and I subtract the same number from both of them, I'm going to still have an equal equation. Multiplication and division are similar. Okay, just to give you an idea of the properties. Reflexive property, here's a new one. Any one thing is equal to itself. So reflexive property generally comes into play when I have two objects that are sharing something. They have something in common. For example, in example 1, the two triangles are sharing a side. I have this triangle right here on the left, and then I have another triangle over here just to the right of it. These two triangles are sharing this side in the middle here. So that would be, they're sharing this middle side right here. So then I can say that AB is congruent to itself, or I can say AB is congruent to BA. The order really doesn't matter when you're talking about line length. Example 2 is I have a large triangle And then I have a smaller triangle on the inside of it. As you can see that they are sharing this angle right here. So I could say that angle DAE, so that's DAE, is congruent to angle CAB because they're sharing the same angle. That is reflexive property. Transitive property of congruence generally comes into play when I have three items that are all congruent to each other. And here's how it works. If angle A is congruent to angle B, and angle B is congruent to angle C, then by logic, angle A and angle C also have to be congruent. So transitive property comes into play again when there's three items that are congruent. All right, here we go. Substitution property says if the values of two quantities are known to be equal, you can replace the value of one quantity with the other. So we've been doing that in algebra all along. If I give you the expression 2x plus 1, and I tell you that x is equal to 2, then I substitute that in for the x and I come up with an answer of 5. In geometry, it's very similar, except we might be substituting an angle or a line segment. So I can show you this example. A plus B in this example is 90. Angle A plus angle B is equal to 90 because of the perpendicular mark. If I say that angle B and angle, let's write it like a proof. So angle A plus angle B equals 90. And then I'm also going to say this is given, angle B is congruent to angle C. Then it has to be true that angle A plus angle C is also equal to 90 by substitution. And I can show you here. I can show you with this angle right here that if I move angle C on top of angle B, that angle A plus angle C does in fact also have to be 90. Symmetric property of congruence and equality says if angle A and angle B are equal to each other, then angle A is congruent to angle B, and angle B is congruent to angle A. So again, congruency and equal are pretty much interchangeable in geometry. It's just a geometry way of writing it. All right, so here's an example of a simple proof. Given our triangle, notice the new notation here. We haven't seen this yet, but you'll be seeing this a lot this year also. Triangle DAE and triangle CAB. So just like we did with angles, we have to follow the roadmap. So triangle DAE. So DAE and triangle CAB. So CAB. It's all I'm given. That's all the only information I'm given. So the conclusion, I have to look at my drawing and say, what can I gather from that drawing? Well, the conclusion that I have gathered is that angle DAE, which is this little angle right here, is congruent to angle CAB, which is the big angle right here, because they're sharing this common angle. And that is called, if you'll look at your notes, that is called reflexive property. All right, given line segment AC plus line segment CD equals line segment CD plus line segment DB. So let's evaluate that really quickly. So this plus this little guy right here is equal to this little guy plus this distance. All right, so what can I conclude from that? Well, I can conclude that line segment AC is congruent to line segment DB. Because if I take out CD from both of them, that's what I'm left with. I subtract it away. So I'm going to go with subtraction property. Okay. All right, very similar. So I have AD minus CB, or CD is equal to line segment CB minus CD. So very similar. If I take away this guy from both of them, I'm going to have line segment AD is congruent or equal to line segment CB. And that is again by subtraction. I guess the one example that was prior, you probably could have used addition instead of subtraction. But either one, I think that you get the idea. You're going to end up with those two line segments being congruent to each other. All right, given A plus B is 10 and B is 7, conclusion is A plus 7 equals 10. And that would be substitution. All I did is I took the 7 in and plugged it in for B. And then I could say that A is equal to 3 by subtraction. All right, W equals X, X equals Y, and Y equals Z. So here I got three things that are being compared to each other, where one is equal to the other, and so on and so forth. So right away, my brain is thinking transitive property. I'm going to skip right to the reason. So I got X, W is equal to X, X is equal to Y, Y is equal to Z. Therefore, W has to be equal to Z. That is the transitive property. Given the diagram, what can I conclude from that? Well, I see two triangles there, and I see that those two triangles are sharing this common line segment. So automatically, I'm thinking that my reason is, well, let's just say line segment AD is congruent to itself. And that would be reflexive property again. So the first one we did had an angle. That one has a line segment. All right, given the diagram, angle AED, so that's this guy, AED, is congruent to, and watch your order here. Okay, it has to go BEC, angle BEC. And if you recall, those are vertical angles, which is why they are congruent. Vertical angles are angles created by two intersecting lines, and they are the angles that are across from each other, and they are always congruent. Given angle B and angle E are right angles, conclusion is angle B, and, oops, not and, congruent to angle E. That is all 90 degrees angles are congruent. Given DB bisects angle ABC, conclusion, well, bisect means it cuts it in half, which means the two angles have to be equal to each other. So my conclusion is angle ABD is congruent to angle DBC, and that would be definition of bisect. All right, given HG, this is very similar to the last one, so my reason is, my conclusion is going to be that these two angles are, oh, that's not, they're not congruent though. All I know for sure is, let's back the truck up on that one because I misread that myself. Okay, HG is bisecting, so this is bisecting this other line segment, so these two things are equal. My conclusion, therefore, is line segment EG is congruent to line segment GF, and that would be property of bisect, or definition of bisect. Either one would be fine. Given HG and EF are perpendicular, so that little sign means 90 degrees, perpendicular. Conclusion that HGE angle HGE is congruent to angle HGF. And again, all 90-degree angles are congruent. All right. All right, that concludes today's lesson. Tomorrow we'll go on to 3.2b, and there's your warm-up for tomorrow.